The Innovation Alliance is composed of 3 departments of the University of Bremen, 2 biological institutes, and as well as another 15 partners from business and industry. The goal of our field experiments is to understand temperature distribution in the container and determine how exactly we can continue to improve the packaging and arrangement of pallets, as well as find out the best sensor positions for detecting problems as accurately and quickly as possible. Transporting bananas takes about 2 or 3 weeks on the North Atlantic. Cooling should be as even as possible so that, as a result, the bananas achieve uniform ripening as well. It is vital to ensure uniform ripening during the voyage. The higher the temperature, the faster the critical state is reached where the banana starts to ripen by itself. Too low below 12 degrees is also not good because there, the bananas are damaged and can no longer ripen. The current temperature is measured in each step, and the number of days or hours of shelf life lost due to the current temperature is calculated. Previously, the FIFO system always worked, meaning the container that came first was also the first to be delivered. Therefore, first in, first out. For us, the approach in this container experiment is to go more in the direction of FIFE, meaning first expire, first out. During the voyage, we are already generating data from which we can derive the remaining shelf life of the goods upon arrival, so that the goods can be accordingly delivered on time. At present, we measure the temperature, the laboratory then reads the data, and from the slope of the temperature curve, we determine how much or how effective the cooling effect on each carton was. And naturally, we ask ourselves, how can we best distribute our sensors so that we can estimate how warm the hottest spot is? The sensors are self-regulating in the sense that the data is evaluated to calculate the remaining shelf life, instead of the meaningless transfer of all temperature data, which would be too expensive for wireless connections. The sensors decide for themselves when a critical situation is reached, and only then will they send an alert. Along these lines, the container experiment also aims to provide us with an automatic remote data transmission.